Hello guys, welcome back to my channel. And those who are new to this channel, kindly make sure that you subscribe to this channel for the latest tech updates and the tech knowledge. So I'm starting a new series from today, which is statistics for the data science, and today is day one for that. Many people just jump into the learning the machine learning models and like training them, but they don't know the science or the maths behind it. So I'm here to help you guys, and today is day one of the statistics for the data science. Now let's first understand what statistics is. So statistics is nothing but a science of collecting, organizing, analyzing, and interpreting the data. Okay, so to make decisions or understand patterns, so you can think of it as like a toolkit we use to turn the raw materials into the meaningful insights. Now talking about the types of statistics, so there are now basically two types of statistics. One is the descriptive statistics and the other one is inferential statistics. Now, talking about the descriptive statistics first. So, descriptive statistics is nothing but summarizes the data and describes the data in a clear way. And the tools we use for that are mean, median, mode, graphs, standard deviation, and cost tables. So, for example, you can think of it like suppose you surveyed 100 students about their exams. Okay, so you found out that their average score was 75, their maximum score, or you can say the highest score, was 95, and their lowest score was, let's say, 40. Okay, so you know like a bar chart showing the score distribution. Okay, so this is a descriptive statistic because you are just describing what happened in that data set. Okay, now talking about the inferential statistics. So if I would say the definition of the inferential statistics, it uses a sample data to make the predictions or the generalizations about a larger population. Okay, and the tools we use in the inferential statistics are hypothesis testing, which I would be talking about in detail in my coming videos. So make sure you follow the series, okay? And confidence intervals, and regression analysis. Okay, so for example, you take a sample of 100 students. Okay, you take a sample of 100 students from a university of 10,000 students. If 60% of your sample prefers online classes, then the inferential statistics helps you to estimate that around 60% of the entire university population might prefer online classes. So this is inferential statistics because you are inferring beyond the data you collected. Now talking about two main terms are population and the sample. Okay, so we will be talking about two more main terms, which are population and sample. So talking about the population first, the population is nothing but the entire group you want to study. So population is like the entire group you want to study. Okay, for example, all 10,000 students in a university, and if you want to know the average height of the student, the population is every single student. Talking about the sample, a sample is a smaller subset of the population. Smaller subset of the population. So, you randomly select 200 students from the university and measure their height, and that group of 200 is your sample. So, why do we use samples? So, samples are used for studying the entire population because studying the entire population is too expensive, time consuming, or impossible, maybe. Okay, you cannot, ask take the height of 10,000 students, let's say. Okay, so, well chosen sample can give reliable insights about the population. So, quick analogy I want to give you is that the population is like the whole pot of soup, while a sample is one spoonful you taste. So, if the spoonful tastes salty, you infer that the whole pot is salty, right? So, that's inferential statistics in action. I hope you are able to understand the example I gave you. So, uh, and you might be thinking like why this matters in machine learning, like, what is the role of this in machine learning? So see, every ML model now works on samples and not populations. For example, your training data, let's say your training data is what? Your training data is nothing but a sample of the entire population. Okay, your training data is nothing but a sample of entire population, while the real world users are your population, correct? So, if your sample is biased, the model performance fails in production. For example, a recommendation system trained only on young users may perform poorly for the older users. Okay. So, summarizing the everything that we studied today, like the descriptive statistics, descriptive statistics is nothing, it's all about what happened, okay? While the inferential statistics is nothing but what does it mean for everyone? What does it mean for everyone? Okay, so this was all about the statistics, like what is statistics, what are the type of statistics, a small introduction about the population and the mean. Tomorrow I will be covering about the types of data like the numerical, categorical, discrete, and continuous. So if you like the content of this video, just like this video, subscribe my channel, and do not forget to hype my video so that I stay motivated. And meet you in the next video of the 20 days of statistics. Till then, bye bye.